One command, 13 resources, VNet, app service, SQL, key vault, private endpoint, all deployed, all connected, and all repeatable. This is what we are building today. Here's what I keep seeing every single time. Somebody joins a new project and then they open up Azure portal. They go through the whole deployment step and then start clicking VNet, app service, subnets, database, and private endpoints. And it works for now. Then 2 months later, they need the same settings in the staging environment. And then they're sitting there trying to remember all the settings, all the configuration, and the resources they need. Infrastructure as code solves this entirely. My name is Praveen Singh, a cloud solution consultant and Microsoft certified trainer. If you're not subscribed to the channel, please hit the subscribe button and come join my learning community. I've got a whole lot of series coming up on Azure automation and Azure infrastructure in the upcoming weeks. And this one today is going to be a big piece of that puzzle. So here's what we are covering today. First, I'm going to explain what Bicep is and why Microsoft built it. Then we're going to write Bicep files from scratch, starting simple and then layering in complexities. We'll deploy it with Azure CLI, preview changes with what if. That will save you headaches down the road. Without any further ado, let's jump in. Alright, let me start with the basics. Bicep is Microsoft's domain-specific language for deploying Azure resources. And here's the thing, if you have ever worked with ARM templates, you know exactly why Bicep exists. ARM templates are JSON. JSON was never designed for humans to write infrastructure in. You end up with the same massive file, hundreds of lines of resource blocks just to deploy a simple storage account. Bicep fixes that. It does compile down to ARM JSON in the backend. Azure still sees the same deployment. What you write is clean, readable, and honestly pretty intuitive. Take a look at this. On the left side, a storage account in Bicep, almost about 10 to 15 lines. On the right side, the same thing in ARM JSON, easily 30 lines with all the schema boilerplate. Same results, completely different authoring experience. Now here's the question I get all the time. Should I learn Bicep or Terraform? And they both looks like same. And my honest take is this. If you already work in an environment where they use Azure heavily, then Bicep is your native choice. Microsoft is investing heavily into the tools that support Bicep deployment and development natively in VS Code. So there's no waiting for provider update, there's no state to manage. However, if you are multi-cloud working with Azure, AWS, and GCP, or in some way a mix of those three, then Terraform may be a right option for you because you get one language that works across all three different cloud vendors. But again, if your world is Azure, consider investing your skill and the time into learning Bicep. And if you're studying for AZ 104 or AZ 700, Bicep is gonna show up on these exams too. So there's that too. Alright, let me jump into the VS Code and we'll start building this together. I've got Bicep extension installed, and if you don't have it, just go to extensions and search for Bicep. It gives you IntelliSense, syntax validation, and the whole deal with writing Bicep code. Let me create a new file called main.bicep, and then let's start with the foundation. A virtual network with 2 subnets. Let me walk you through what's happening here. The first parameter, I'm using params to define a location and the environment prefix. The location defaults to wherever the resource group lives, and this is a very common pattern. The prefix is let me reuse this template for dev, stage, and production environments. Same code, different names. And then comes the resource declaration. You give it a symbolic name, a VNet, VM, or a storage. And that's just for referencing inside the Bicep file. Then the resource type and the API version number comes. And here's the pro tip. Always use the latest API version. I've seen deployment fails because you've copied over a template from somewhere on the GitHub, which was using 2 years old API versions. Those APIs have been deprecated over time. Notice those 2 subnets. The app subnet has a delegation to Microsoft Web Server Forms. That's because we are going to do the VNet integration with our app service later. If you don't add this delegation in place, the VNet integration will fail and you will likely spend hours trying to figure out why. I've seen this happening in the client environments more times than I would like to admit. The pre-subnet is for our private endpoint. You want to keep this in a separate subnet. Alright, so now let's add the actual workload. App service, Azure SQL, and key vault for storing secrets. Because if you're hard coding connection string in your app settings, we need to have a conversation. Here's where it gets interesting. Look how I'm referencing app service plan from within the web app resource. That's a symbolic reference. Bicep automatically figures out the dependencies. You don't have to write depends on block anymore. Bicep sees the web app depending on the app service. So it's gonna make sure the server farm is deployed first. That's one of those quality of life thing that makes Bicep much more easier to work with. Now notice the @secure decorator on the SQL admin password. This is super important. Without it, that password shows up in the plain text in your deployment logs and in the Azure portal deployments, history, and everywhere else. With secure, Azure redacts it. Always mark sensitive parameters as secure. I've seen credential leaks in client deployments because somebody forgot this one decorator. And here's another thing. See how I'm using unique string resourcegroup.id for the names. App service names and SQL names have to be globally unique across all of the Azure Azure. This function generates a deterministic hash based on your resource group ID. Same resource group, same hash every time. Different resource gets a different hash. It's repeatable and unique. And that's the pattern you want in production environments. Alright, so now here's where we go from demo to production ready. Private endpoint, because right now our SQL database and key vaults are accessible over public internet. And in any real environment, especially government or financial, that's a non-starter. So what's happening here? We are creating a private endpoint in our pre-subnet that comes to the SQL server. That's a private DNS. Then a private DNS zone so that when our app service resolves the SQL hostname, it gets the private IP address instead of the public one. And then we link that DNS zone to our VNet. Here's the thing. This is the part that trips people every single time. You need all three things: private endpoint, private DNS zone, and the DNS zone link to the VNet. If you miss the DNS zone, your app will still resolve to the public IP. If you miss the VNet link, the VNet doesn't know anything about DNS zone. I've got a whole video coming up on private DNS zone where I'll go deep into this topic. I'll link it in the description below when it's out. Alright, so the moment of truth, let's actually deploy this thing. Let's create a resource group and take a look at this output. It's showing you exactly what Azure is going to create with the colored coded breakdown: green for create, yellow for modify, and red for delete. This is your safety net. In a CI/CD pipeline, you would run this in a pull request so your team can review infrastructure changes before they go live. This is very, very important in production. Now let's actually deploy this. And now we wait. This is going to take a few minutes because of the SQL server, private endpoint, and everything behind the scene. Bicep is compiling this to ARM template in the backend and submitting it as a deployment. Azure Resource Manager, which is the ARM, handles the orchestration. It figures out the dependency chain, deploy things in the right order. Alright, let me jump over to the portal, and there it is. Every single resource we defined in our Bicep file deployed and ready. VNet, app service plan, web app, SQL service, SQL database, key vault, and all that stuff. And if you're following along and you need the access to these files, you can check out the GitHub repo link in the description below. And now if I go to deployment blade, I can see the full deployment history as well. Every deployment is tracked. I can see what changed, when it changed, and who triggered it. This is your audit trail. Here's what most people miss. If I run the same deployment again with no changes, nothing will happen. It's idempotent. Azure compares the desired state with the current state and only applies the delta. Same concept as Terraform plan, except Azure manages the state for you. So there's no state files for you to worry about. So backend configuration and no locking issue. Now let me show you something that's relatively new and honestly a game changer. Deployment stacks. This is how Microsoft solves the lifecycle management problem. With just regular deployment, if you remove a resource from your Bicep file and redeploy, Azure just doesn't touch it. The resource stays there, orphaned. With deployment stacks though, you can tell Azure what to do with the resources that are no longer in your template. Two things happen here. First, action on unmanaged, delete all. If I remove a resource from my Bicep file and run the stack again, Azure is going to clean all of those orphaned resources. So no more ghost resource sitting in Azure costing you money. The second is deny setting mode, deny delete. This puts a deny assignment on the existing resource so nobody accidentally deletes anything. You literally have to go through the stack for that. And this is what I use in the client's environments now, especially for the production. You get the lifecycle management and the protection for accidental deletions. If you are used to the Terraform delete behavior, then this is probably the same in the Azure Bicep. Before we wrap up, let me hit you with the one mistake that people make when working with Bicep. And these are straight from my client projects. Mistake number one is the resource scope confusion. A resource group scope deployment cannot deploy a resource group itself. Your deployment has to be scoped on the subscription level for you to be able to create or manage a resource group. I've seen people bang their head on this one for hours. Number two is forgetting to register the resource provider. If you've never deployed a key vault in your subscription before, there's likely a chance that you may not be able to deploy it until you go to the resource providers, look for the key vault, and register that provider. This is a basic safety net that Azure subscriptions have. It's highly likely that you would have to go in and ensure the resource providers you want to use are enabled. Number three is API version mismatch. I've seen people copy paste Bicep files from different GitHub repos, and some of those codes are almost 2 years old, using different APIs, especially the APIs that have been deprecated over time. And here's one of the biggest mistake I see is not using parameter files for different environments. I see people duplicating entire Bicep file for production versus development environment. You don't need to do that. One deployment file with prefixes can handle multiple parameter files. dev.biceprams, prod.biceprams, even staging. Same template, accepts different values. Alright, so there you have it. A complete Azure environment, networking, SQL, compute, app service, all deployed from a single bicep file. Once you understand this and start using this, spinning up new environments is literally one command. If you're coming from Terraform, I've got a Terraform video on my channel as well. I will link it in the description below. If you want to go deeper into private endpoint and DNS zones, those videos are coming up soon. If you found this helpful, please let me know in the comments and share what you're deploying with the bicep. I would love to hear from you, and if you're not subscribed yet, please hit the subscribe button and come join my learning community. I'll see you in the next one. Until then, stay curious and keep building.